Thank you, Malcolm. And good evening, everyone. It's nice to see that, by the look of it, pretty much everybody made it here, which is fantastic, and we know there were some issues there. Look, my job is not to so much give you a lot of information, but really just to put it into context. As Malcolm put it, why do we care? I'll give you a little bit of a personal story to begin with. When I was a graduate student at one of our major universities in Sydney, I was going along to a number of debates that were happening on campus, particularly about origins. And there was a whole lot of things that were brought up, and I wish I could go into some of the detail, but this is not my time to do it. And I'm just looking to see whether there's any clock or timer, and there's not, so I've got plenty of time. Okay. All right. I was going along to these, and look, I was even taking participating as one of the debaters from the floor on certain topics. But as I went further and further along, I began to be convinced that actually evolution must be true. And I remember where I was walking. I could take you to it. I know what the day looked like, everything, because it was such a life-changing experience. I was walking across the campus outside outside the Biological Sciences lawn, and it just hit me. Evolution is true. And therefore, if evolution is true, I cannot be a Christian. Now that was a big shock, because there's a lot about Christianity that I liked. I think certainly the principles and the morality and what Christianity has done throughout the world, throughout centuries, in fact millennia, is extremely powerful. But I could not be an honest Christian if evolution were true. I couldn't. So, unbeknownst to my wife and also my broader family, I was telling my mum about this about a year or so ago, I was probably considered myself probably more an agnostic, probably an atheist to agnostic, for about the next 18 months. But what I did, and particularly having a few more skills as a graduate student, I just didn't accept what I was being told. I actually did a lot of study behind the scenes. Some of you would know the book by Ian Plimer, the University of Melbourne. He's retired now, geologist. But Telling Lies for God. You know, some of those arguments, and I was working through those. Now, at the conclusion of that, I actually came to the conclusion that what I had been in was more of a movie set than a real town. You know, if you walk through a real town, like you can do here, it's almost real here on the Gold Coast. You know, you can walk down alleyways and everything looks genuine. You know, you'll go down and you'll see. Whereas if you walk through a movie set, when you're looking left and right, you'll actually say, oh gee, that looks like a real house and people are doing real things. Until you go down an alley or two and look behind and you go, hang on a minute, that's just a facade. And then you'll come out and you'll go down the next one. That is exactly my experience. Until I got to the end of about 18 months, and I remember saying things like, Carelda, I mean, it is just... Look, and I'm sorry, I said that I wouldn't use the term stupid very often about some of these things. But the concept, particularly for me, now, I don't get up to give talks in this particular conference because I don't really know much about the topic. I'm a life scientist, so clinical biochemist, biochemical pharmacologist. So I know more about how life works and the complexity and all of that sort of thing. And so I was coming from that direction. But to tell me that life could start by any of the mechanisms and could continue to develop from any of the mechanisms that are currently put forward in science, and I've had many discussions with many people, absolutely impossible. So what I want to do for you today, this evening, is just give you some context as to why now, with this conference, we'll be talking about geology and that type of thing. How does that relate to this concept of evolution? Because it's really about the introduction, the evolution, or the origin of life. So as Malcolm mentioned, we did have another conference. Let's make sure this is coming through. And to begin with that, I'm going to try and coordinate both of these so I don't have to keep looking up here. But the issues relating to the existence of things, they're divided into three main areas. The origin of the universe, fair enough. We had to have a universe to be here, space, time and matter. Then there's the origin of the earth, which is physical features. And that's the one that we're going to be talking about today. And then there's the origin of life, the man, animals and plants, all of that complex life. Now there's going to be a bit of logic, so please follow me through as much as you can. From the origin of life, you could step down into the origin of carbon-based life, self-replicating systems, the origin of increasing complexity. We all started with a single gene. We all started with a single cell, didn't we? And then ultimately, you get to about eight these pluripotent stem cells, and then you get to 16, and then they start to differentiate. All of the information that allows them to produce everything that ultimately is you had to be there from the original cell. Incredibly complex chemistry. So increasing complexity we would have to if you followed the general paradigm. And then origin of sentience. Anybody know what sentience is? What is it? You can pretty much just, you know you exist, you're able to function on your own. What about sapience? It's a sense of morality. It's actually really, we think it's only in humans, but essentially that sense of morality, that sentience or sapience. Now, Seminar 1, which we did back in 2019, dealt with all of this sort of stuff. I'll give a little recap on it, but that's essentially what we did there. And just as a quick review, we talked about the improbability of gene development by random mutations. Wow. It goes beyond what we call the probabilistic resources of the universe to get really one functional gene, and you start putting them together. Look, I'm very happy, and I know that this is not a conference specifically on this part, but I know some people might have questions and they want to even take me to task or be aggressive. Come and talk to me afterwards. I'm very happy if you want to shout at me in a corner. I'm certainly not averse to that, having been an academic for some years, and I've had people stand up at international conferences and tell me I didn't know what I was talking about. Of course, I can explain that I did, but... we talked about things like relationships with human DNA, improbability of gradual development of interdependent ecosystems. I just need to stop there for 1 minute. I'm conscious of the time. But this interdependent ecosystem, think about it. If we actually did develop as life, and know how our ecosystem is complex at the moment, isn't it? Aren't we all worried about, or at least the world, everybody is worried about the fact that we've got ecosystem parts of it that are being destroyed, and therefore it could destroy all of us, whether or not it's the bees or whether it's the water or whatever it might be. Can you think, if we are all interdependent on an ecosystem which is highly complex now, could you think of a scenario where, as we're developing from your prototypical organism, which was single cell to begin with, up to what we've got now, every single stage of development had to have been within an ecosystem that was supporting itself? Does that make sense? So the ecosystem had to somehow develop at the same time as you're getting random mutations happening for different things to develop. The impossibility of that is beyond ridiculous. Historical evidence for the lineage of man, etc. Understanding evolutionary mechanisms, and Professor Brand will be giving us some talks this time as well. And then, most importantly, and I'm going to talk about this a little bit at the end of my talk here, we were putting this within the context of what the Bible says. And we have a number of scholars here that are going to give us presentations in relation to the Bible too. I'll present just shortly. But this is very important to put what we're seeing here within the context of the Bible. And I want to unpack that a little bit later on for you so you understand why we actually need the two. So what were our key conclusions that came from this? Well, basically, living organisms, extremely complex, and unfortunately not really able to be produced by the mechanism of neo-Darwinian evolution. So, extremely complex. There is no way we can produce it by neo-Darwinian processes. Fossil record, not consistent with the gradual evolution of life. Now, there are certain gradations within the fossil record, and that's going to be touched on also within this seminar, but certainly not producing the sort of stages in life that we see, what we would need in order to produce us. And then a clear understanding of the biblical text dealing with the origin of man strongly supports the creation by an omnipotent God. You know, as I said, within my own experience, there was no possible way that I could look honestly on what the Bible was actually teaching and come up with any kind of evolutionary scenario. Happy to discuss that further with those people who would like to. So while an evolutionary origin cannot provide a solid foundation for human morality, and that's just as important, it is just as important for us to explain, because that's what origins are all about. They're about explaining not only the physical organism and the world around us, but it's also explaining what makes up humanity. An important part of humanity is we do have a sense of morality. We have a sense of right and what's wrong. How did that get there? So the origin of life, an overview of the current state of knowledge, may surprise some of you. What's our current state of knowledge? And this is within science itself. So if we talk about the pre-universe, this is what happened before the Big Bang. What do we know? Nothing. Really. And what about the arrival of space, time and matter? And it's talked about in physics, quantum flutter, and there's not really anything more than that, and that's really just a term for we have no idea. Not observed, mechanism unknown. What about the generation of life and its generation of the Earth and its physical features? Still don't know. Initial origin, not observed, but features explained by either uniformitarian or catastrophism. That's what we're dealing with, and particularly the role of flood on that, a universal flood. It's interesting, I had a friend who was an academic with one of the universities in Melbourne, and he came up and stayed at our place for a weekend, and fascinating thing for him, he's somebody who is he's an applied mathematician, and his PhD was actually in astrophysics, looking at the angular momentum of the universe. Now, you don't have to worry about what that is, but most things spin. In any case, he was trying to use the theory of general relativity, in other words, Einstein's theories, all about the Big Bang, that type of thing. He was trying to use that in order to explain why the universe looks the way it does. Well, he got to the end of that and realised that you couldn't do it from the current theory, and in fact became a six-day creationist as a result. Fascinating to talk to somebody who actually does know how to use the maths in general theory of relativity, which I don't. Generation of chemicals needed for life. Does anybody know where they came from? Look, there's some theories, but nobody's really established on that either. How these chemicals coalesce to produce the genes, proteins, organelles? No, nobody knows. Nobody's observed it, they don't know. There's a few molecules that were produced, you would know the Euromillier experiments, but look, they're racemic mixes, none of them actually go beyond a dirty mixture. It's not producing what we actually need. And then the random mutations, best surviving protocell, not observed, but mostly we're seeing similarities between certain things. 5 fingers here, 5 fingers there. That's a lot of how biology links itself, by going, look, that looks like that, and that looks like that. How we can actually get, and I think I remember this particularly being in Africa, when the closest relative to the elephant was the rock badger, I think. It was either the elephant or the rhinoceros, I can't remember. I'm not sure how they actually get that, but a lot of that is just done simply through phenotype. I had a colleague of mine, he was actually an honours student, who was looking at the relationship between elasmobranchs, but basically sharks and stingrays and that type of thing. And he was going to go and do his PhD, South Africa, looking at the relationship between those. He was a strong evolutionist, and I told him, you won't find a relationship between the genetics. He said, no, I will. Anyway, once he'd finished his PhD, came back to Australia, he's working now in South Australia, I rang him up and I said, how did you go with that phylogenetic link? In other words, looking at how the genes all work together. Anyway, he used a little bit more colourful language, but he said basically there was no relationship he could find at all. All right, targeted, self-breeding, natural selection. Yes, natural selection absolutely works. That's an important process for keeping species alive and helping them to adapt to niches. It's widely observed and verified. Gene duplication, transfer shuffling, these are all observed. But no verification of any from nothing, new gene formation, or increasing in the gene pool complexity. When you select within that, as most of you would know, when you select from a gene pool, when you take something away from something, are you increasing its complexity? You're always decreasing. Very quick story, I realise where my time is going, but if we were to take a population, this population here, and let's say we all got stranded on the island that Malcolm was out in the middle of and they didn't manage to make it back. Now, if we were stranded on that island and we need to keep breeding from that island, the only trouble was, in this particular island, you'd have to swim across a 300 metre, let's make it 400 metres, of channel, which always had a current going through it at about 3 knots, in order to get your water, and there was nothing to bring the water back. So everybody had to swim across in order to get their water and then swim back. Who are going to survive? The strong swimmers are going to survive. And as I like to point out, that usually means that the mathematicians and the biologists probably won't make it. But the point is that it's only going to be the strong swimmers. So would we lose quite a number of people from here? Yeah, so what happens to all of those people with the expertise that didn't make it? Have we made that population, in a sense, that population has evolved because they'll be strong and fit and healthy and have all the good genes. But we've lost a whole lot as well, haven't we? So we've actually lost genetic information, we haven't added to it. That's what we observe, that's natural selection. So Seminar 1, again, covered that off for us. Seminar 2, which is this one, is actually going to look at this bit here. So initial origin, okay, essentially what the relationship is between what we're seeing on Earth and how it relates to a global flood. Now, if you don't have a global flood, then it means a lot of the things that are observed can be interpreted in a way which can sort of add lots and lots of years. Make sense? But if there is a global flood, then it means that that needs to be interpreted quite differently. Is that correct? So whether or not it is there or not, and is there an implication if there is a flood or isn't a flood relative to the Bible? Yeah, absolutely there is. So knowing whether or not there's a flood or not, but I'll talk about some of these things. Let me just take you through some of the logic here. Evolution as a concept relating to the survival of the fittest, which we've just reviewed, has no relevance in the quest to understand the origin of physical laws. Does that make sense? It's not related to it at all. Space, time, and matter. And evidence, if it exists, that the universe is billions of years old, does not logically imply that organic evolution is true. Is that also right? You can have billions of years, but it doesn't mean that evolution is true, because evolution requires a mechanism that gets you to increase complexity. Time doesn't do that. The existence of space, time, and matter are required for life, but do not logically imply a mechanism for its production. I like to point out to people, if I took, a couple of things and put them out on the gravel outside and left it there, what's going to happen within the next, I don't even have to get out to 10 years, but within 5 years, what will happen to my 2 pieces of equipment here? They'll, of course, disintegrate. And if I had an atmosphere which didn't have any oxygen or any other protective mechanism in it, we didn't have an electric field, etc., they would disintegrate a whole lot earlier. You could leave them there for 1 billion years. What's going to happen? Completely, they won't exist. They'll completely degenerate. The existence of space, time, and matter, these are not, or at least time itself, is not creative. So time as an entity is not creative. Even very long ages, deep time, is not able to produce complex information. So it's almost a point where, almost regardless of what you see in relation to time, it doesn't mean that evolution is true. There are some implications in relation to the Bible, and it is important there, and we do need to look at it. But it's not telling you that evolution is true. So the origin of life and its physical features, explanations for geological phenomenon, they have implications for the existence of long ages and in relation to Noah's flood. So they have some implications on how we interpret the Bible, but even long ages, if they exist, do not logically imply a mechanism. So though neo-Darwinian evolution requires very long ages, even if they exist, do not logically imply evolution. So yes, those that are into evolution have to try and get long ages out of things in order to get any kind of credibility to what they're trying to produce. But it doesn't itself tell you that evolution is true. So, series 1, we dealt with the origin of complex life, provided clear evidence that as a theory, Neo-Darwinian is completely incapable of explaining life's origins. It is. In Seminar 2, we'll be looking at how various features of the Earth developed and whether the data, both physical and paleontological, are consistent with catastrophism, including a global flood, and that in relation to uniformitarianism. So, some excellent talks that are coming up, and this is just a preview. These blue are all, these are in relation to the Bible. And notice that it's important to have the Bible in its context, and I'm going to tell you a little bit more, hopefully explain a little bit more why that's the case. History of catastrophism, uniformitarianism, we need to know how things started, or what the motivation for why things started. Colossal nature of volcanic activity. Now we have a man who, and I remember meeting Berger a number of years ago. Now he's from Iceland, and he says, you can tell an Icelander. How do you tell an Icelander? Basically he says, if a volcano goes off, everybody else runs away from the volcano. But Icelanders run towards it, which is why he's a volcanologist. Lots of things, lots of volcanic activity there, which is why it's easy to find a hot pool to nestle yourself in. So, interesting, exciting to hear what that comes from there. Professor Brand is going to be talking about some large-scale sedimentary transport, biblical flood and its relation to the Bible, some fossils, Ice Age chronology. Now, particularly in Adventist circles over a number of years, there have been some questions, or certainly people who question, in relation to ice cores and things like that. Michael Ord is going to give us some, I think, some very pertinent information in relation to the interpretation of some of these. So definitely look out for him. Paul Geam is going to look at critical approach to radiometric dating. I mean, always one that comes up in relation to time. Now remember that time is not going to tell us that evolution is true. But we still need to understand how you get this deep time, which seems inconsistent with certainly the Bible's chronology. And soft tissues, I mean, Susan Phillips, that'll be very interesting. If you've got an animal which is supposed to have been dead for 1 million years or so, even 100,000 years, how is it possible that you've still got some soft tissue there? Good to explore that one. And we've got a number of others. Ice Age and catastrophic models of origin. I think that's going to be fascinating to just hear how we actually do get our ice ages. Was it 1? Was it 2? Was it 50? Plate tectonics again with Berger. And what I'm particularly fascinated about is these flood stories. And most of us would know that there are many, in fact there are thousands of different people groups around the world that have flood stories that have a lot of consistency between them. Be interesting to see how, and where does that come from? So our objectives really for our Seminar 2. As for the previous one, it seeks to provide you with both the factual and up-to-date physical and scientific data, as well as a clear and honest overview of what the Bible teaches as it relates to these topics. So let's have a look at the Bible. Why is an accurate biblical understanding so important to understanding truth, even when dealing with physical things? Why do we need the Bible there? Let me put a couple of things out for you. First thing is, how do most people make decisions? In other words, how do you become persuaded about something? And there's some theories around. This one is actually probably the most common, and I think it works very well. They say that there's 2 ways in which we learn, or the majority of people will learn. Number 1 is what's called the peripheral route. So an indirect route that assesses peripheral cues to associate positivity or negativity with the message. And an example of this is celebrity endorsement of, a pair of shoes or some clothing or something like that. In other words, somebody that you admire, somebody that you look up to, says that this is a good thing, and therefore you go and do it. You haven't studied it out yourself, but you have the impression that this is a good thing, and whether or not you just want to look like them or feel like them or somehow be associated, you'll buy it anyway. That results in what we call it's a fairly transient change to attitude and behaviour. It's less permanent usually, but it's actually probably the most common. In fact, those of you that came here almost by any vehicle, but I can just say by aeroplanes, how many people knew the detail of whether or not that plane was going to make it here or not? Doesn't matter whether you came from Vanuatu or Fiji or the US. How many of you knew the detail? Not too many. You pretty much got on it because most of the time planes do make it to their destination, and you trust the people that are going there, and you also wanted to come to the seminar, so you wanted to sort of push any of those negative feelings out of the way. So most of your decision making was by the peripheral route. However, let's just say that you go, no, I'm going to definitely go through, and this is the next one. So you're forming a subjective truth for that first one. The second one, which is the central route, this is actually the one that we want to get to in this seminar, or provide for that. It's a direct route where logical assessment of the data and facts occurs. In other words, you buy a computer because it has these features, etc. Or you hop on a plane because, and let's just say you said, I want to make sure I use all of my thinking, and so I'm going to go the central route. And so you ask for the engineer's report. You make sure that you talk with the pilot and you get his detail and the weather, and make sure that the weather was going right. And you make sure you get all of the manuals when it's relation to any of the things that are associated with hydraulics and whatever, and you pile them up. How many of you would be able to, first of all, you wouldn't get access to all of that information, and second of all, even if you had it, how many here would actually be able to understand all of that information? None of us. None of us. So we need some sort of a foundation on which to follow. So if arguments are strong and this is the method that you want, that's what we're looking for, forming an objective truth. But, and this is where the problem is, humans need some assistance when forming objective truth, because we actually are incapable of obtaining, first of all the facts about anything in complete objective data, and second of all, where even if we have all the facts, man is almost certainly incapable of understanding the precise and complex integration of those facts relative to each other. We almost certainly can't put all of those facts together, even if we had them. Therefore, we have to have something else. Evaluation and synthesis of the objective data, the physical facts, within the moral and practical framework provided by the Bible is essential to arrive at an understanding of reality in the decision-making process. This is not a seminar given for people who don't have an understanding and a foundation of the Bible. Am I correct? We're all standing solid on the Bible. And why? Every one of you have got your own reasons. And you have looked into it, you have looked into the morality of it, you looked into, whether or not it's factually correct, etc. But we accept the Bible as a foundation is incredibly strong as a foundation for humanity's existence, etc. But the Bible doesn't give us all the detail in relation to the geology. It doesn't give us all the detail in relation to the biochemistry. But as a foundation for understanding how the world works, it gives a framework which seems to work every time it's applied well. Am I right? Every time the Bible, and I'm not just talking about anything that's labelled Christianity now, I'm talking about any time the principles of the Bible are actually applied to any society, I would strongly argue that it had always produced a benefit. As I said, I'm not just talking about things that are labelled Christianity. There's certain things that are labelled Christianity that can produce terrible things in a society, including wars, etc., but not Bible-based Christianity. So the Bible is actually a terrific way of being able to form, or at least help us create the right sort of context. Only by acknowledging and allowing ourselves to be informed by revelation from our Creator God can we correctly orient our interpretation of data. Now, I still have a couple of minutes, so I want to give you a little personal example if I can. And I love this quote from Proverbs 9:10. The fear of the Lord is the beginning of wisdom. Absolutely is. There's no question that, we've all got differences of opinion about certain things here, and certainly within the wider academic community, there's lots of differences of opinion on different things. You can be extremely intelligent, but still be very, very wrong. This is my little example. As I said, this is my only chance to actually give you a little bit of biochemistry, but I'll do it here. A number of years ago, in fact, this is back in the 90s, This was a pathway that we were starting to research. And it was interesting looking at it. Does everybody know tryptophan? Tryptophan is an amino acid. You sort of know it in relation to, most people have heard of serotonin and melatonin. Okay, serotonin, kind of the feel-good molecule. Melatonin helps you go to sleep at night. Things like milk and also soy milk have plenty of things like tryptophan in them. So that nice cup of milk at night people would want to do so that they would get their melatonin and therefore drift off to sleep, whether or not it actually worked or not. But the point is, this is actually the pathway that produces it. Serotonin, melatonin from tryptophan. But when you get infected with something, if you get inflammation to the body, and we were particularly interested in the brain, neuroinflammation, what we called it, this pathway would get switched on. It's called the kynurenine pathway. It would drag the tryptophan away down this pathway here, and there's a reason why I'm telling you this. There's a molecule at the end here, which is called quinolinic acid, and it's actually a neurotoxin. So back in the 90s, there was some, and as I said, my background is neuroinflammation, clinical biochemistry, neurochemistry, and the big wigs in this area were all saying, we should, this is the cause of things like Alzheimer's disease, AIDS dementia complex, various other things as well. Therefore, in order to stop this from being such a problem, we need to inhibit this pathway. In other words, you can find inhibitors, that's what a lot of drugs that you take do, they inhibit certain things, whether it's receptors or enzymes. So let's find a drug that inhibits that, or at least let's find a molecule that inhibits that, make a drug out of it, and we'll solve this problem. And sure enough, and this is particularly one of the big wigs, mechanism quinolinic acid, where they've actually inhibited it in order to produce the result they were looking for. The only trouble is, when I looked at this pathway, I thought, now, you've got to remember that most scientists are atheists, or at least evolutionists, and so as a result, they're looking at this and going, this is probably some sort of evolutionary vestige. It was a leftover from somewhere, it's probably not that important. Let's just inhibit it. We don't know what any of these other molecules do, actually, and so let's just inhibit it, there shouldn't be a problem. When I looked at it, I thought, this is a complex pathway which is highly controlled by a number of different enzymes all through here, and I thought it just doesn't make sense that you would want to inhibit this pathway. So I thought, what actually does quinolinic acid produce, and would it have an effect on this, on the body if you actually do produce it, affect it? Well, the molecule that it produces is a molecule called NAD, and we were some of the first ones to show how related that was with things like DNA repair and producing energy of the body and all of that sort of thing. And we then looked at this and published a few papers, that's quite a while ago, and we got a number of them, but basically showing that if you inhibit this, you actually drop NAD down to the point that you actually kill the organism. Now, they are actually starting to use this in order to kill cancer cells, so it does actually kill things. But the point that I'm making is, we wouldn't have seen this, and we've got some of the seminal papers in this area where we've got, anyway, lots of people that have referenced it because of that. But we didn't, how was it that we knew? And we've had people, I had a lady who was doing some, she was a reporter wanting to do a story on NAD. It's actually a big thing in the sort of anti-aging group and things like that now. And she'd been over to Harvard and interviewed one of the researchers over there who had been working on this, and they said to her, look, you really need to interview Ross over there and we have our research centre at campus at Sydney Adventist Hospital, and she came over and interviewed us there. But when you look at the difference between Harvard, now you have a look at some of their research centres, and the particular guy, I know him who's doing the research there, and you look at their centre, it's this, spiral staircases and big beautiful building. You come over and you have a look at our building, and it's a little demountable at the end of campus if anybody's actually seen it. And, she's coming through and she's interviewing me and she's impressed and I'm explaining to her. And then she turns to me and she says, it's just amazing, like compared to Harvard, that you could be doing such world-leading research here. And I just chuckled and I said, well, you don't need a lot of money in order to have a good idea. And that's true. And the fact that the reason why we weren't smarter than anybody else, but the fact is that we could see further than they could. Why? Because there was a foundation. It was a creator God who actually put this together. And we were looking at it from that perspective. And if there's anybody here who is in research who even might be an atheist, if you want to get further in no matter where you are, assume that the universe, the solar system, the world, and certainly any living thing was created, and expect there to have been incredible design behind it, and you'll get a lot further in your interpretation of the data. Does that make sense? Absolutely it does. And that's why it's so critical for us to have this as a background. So it's the hope of the organisers that we'll take the opportunity during this seminar to gain the knowledge, ask questions and challenge concepts, both technical and theological. You're allowed to ask questions. As Malcolm was saying, we need to make sure that when we're asking questions, particularly in the sessions, that you do it respectfully. And if you have anything further that you want to discuss, and as I said, not that I'm presenting in those technical areas, but I'm not uncomfortable with people being animated with me outside. That's totally okay. And I'm sure we'll be able to come to some kind of an agreement there. But importantly, we want you to integrate that, what you learn, and make sure that all three elements of truth are satisfied. So your final truth should be, is that final truth consistent with the moral and practical standards of the Bible? Has to be, doesn't it? Because the Bible's the foundation on which we stand. And then ultimately, and you've already proved that, you've got that essentially separate from here. But the Bible being true, it needs to be consistent with what we're seeing. There's been just so many times where people have thrown out the Bible for the sake of science, and I can tell you science changes a lot. And two, the objective truth, we need to make sure that we're not playing fast and loose with the objective facts either. Now, there are some things that are going to sit on the shelf. Even in this next couple of days, you're not going to get the answers to everything. You'll get a lot of answers, and you'll be given some good perspective, but you won't get all the answers. And then finally, and I debated whether I should put this in actually, but subjective truth. I actually do think that when you've got biblical truth and objective truth, it will then all fit together so that it feels right. And I know feelings aren't something that scientists have much of. My wife will tell you that that's true. But the point is that there is a symmetry to it, and it does all connect well. So when it all connects well, you kind of get it. So I think biblical truth, consistent, objective truth, consistent, and then ultimately this comes correct. So look, by God's grace, we just pray that you'll have a great integration of information over the weekend, over this next few days, and I pray that you'll get a blessing from it. Thank you.